JDK, comma JRE, comma JRE, comma JRE, and JVM, and JVM. Pay attention, a very important topic, frequently asked questions in the interview. Thousands of times they have asked this question in the interview. Pay attention. Now, whatever the Java software that you people will be using, it is divided into two categories. The first category is JDK and the second category is JRE. So your Java software is divided into two parts. One is JDK, another one is what? JRE. Okay sir, what is JDK, what is JRE, what is JVM? Pay attention. Now assume I am a developer. This is my computer. This is my computer. So this computer is used by one fellow called as developer. You know what is the duty of the developer? The duty of the developer is to develop the code. Not only that, he should also execute the code. So that is the duty of a developer. So you should be able to develop or write the code and also execute what? Code. Always remember, if you want to develop Java programs and if you want to execute Java programs, then you should install one software in your computer. That software is only called as JDK, which is nothing but called as Java Development Kit. Look at the name, Java Development Kit. So, in order to develop these Java programs, I am going to give one kit. That kit only is called as what? JDK. Okay, sir, inside this kit, what will be there? Have you heard this word beauty kits? What ladies will carry whenever they go for any functions and all, they carry this beauty kit. When you open that beauty kit, you know so many things will be there inside. Lipstick will be there, eyelashes will be there, perfumes will be there, etc. Cricket kit. When you open the cricket kit, you have this bat, ball, wickets, all those things. Like that, when you open the JDK, that is Java kit, what will be there? In the diagram I will tell you. But you understand what is JDK? JDK is a software which helps you to develop Java programs and also what? Execute. And if you ask who will use this JDK? Developers, in order to develop what? Java programs. Am I completely clear up to this point? Next, if you ask me, sir, what is JRE, sir? Pay attention. Now assume I have one more computer. This I will call it as computer 2. This computer is used by the client computer. Now what client will do or what customer will do? Customer will not develop the softwares and all. They will use the softwares developed by whom? Developer. In other words, whenever you want to use, means you want to execute. So whenever you want to execute Java programs, then in your computer, you should use your one software called as JRE. That JRE is called as Java Runtime Environment. Look at the name, Java Runtime Environment. So if you want to run the Java programs, then you use one software called as what? JRE. And who will use that software? Customers or client. And using this software, what you can do? You can execute only Java programs. So I repeat, if you want to develop and execute the Java programs, then you should use JDK. But if you want to execute only Java programs, then you use what? JRE. So these are all the two softwares or two versions of what? Java. Now think and answer. In our class, will we use JDK or JRE? JRE, huh? JRE. No, JDK. Because we will develop the Java software also and we will execute the applications also. So we are going to develop two projects. Two projects we are going to develop and we are going to execute that. So hence we are using what? JDK. Now do you understand what is JDK, what is JRE? Next, if you ask me, sir, then what is JVM, sir? Pay attention. Now assume you have written the Java program. Java program you have written. And this Java program will be in which language? High level language. So high level language means the code that user can read and understand. Usually it will be English. Next, this will be given to one fellow called as compiler. What compiler will do? Compiler will generate one file called as what? Class file. And inside that class file, what will be there? Bytecode. What is bytecode? Bytecodes are such code which is obtained by compiling a Java program. It is not high level also, machine level also. It is an intermediate code. Now, any Java programs to execute, it should commence it on what? RAM. So it should commence it on RAM. Pay attention, very important point. Now, how can I put this class file into the RAM? So for that, I will use one fellow called as what? JVM. So JVM will help me to put this class file into the RAM. So now this class file is present in the RAM. So who has done that job? JVM. What is JVM, sir? JVM stands for Java Virtual Machine. Java Virtual Machine helps to load. What loading? Class file. So Java Virtual Machine helps to load the class file onto what? RAM. Not only that, your JVM also helps me to execute class file. How it executes, sir? Very, very important. Pay attention. Now, after the class file is loaded onto the RAM, now what JVM will do is, JVM will read the first line of the bytecode, then it will interpret. Interpret means what, sir? Converting the bytecode to native code or machine level language code. That procedure only we call it as what? Interpretation. So JVM will read the first line, interpret, and with the help of microprocessor it will execute. Next, it will read the second line, again interpret the second line. You know, interpret is nothing but conversion of bytecode into machine level language code. Again it will execute. Like that, line by line it will execute. Now think and answer. Is JVM a compiler or interpreter? Already in the previous class I have given the points on compiler and interpreter. What it is? Compiler converts the entire code at once to what? Machine level language. Whereas interpreter converts to machine level language code line by line. Hence, your JVM is what? An interpreter. So line by line it will convert. So what are the uses of JVM? JVM helps to load the class file onto RAM. Not only that, it will read every line, interpret, and helps for execution. Who will make use of this JVM? A person by name called as JRE. So whenever JRE want to execute any Java programs, JRE will ask JVM, please help me to execute the Java programs, and like this your JVM will help to execute it. What I am telling is just an overview. In the next topic, in detail you will understand. In simple words, whenever you want to develop any Java software and execute, then in your computer you should install one software called as what? JDK. If you want to execute only Java programs, then you will install only what? JRE. Very important point. In your computer, by default, JDK and JRE will not be there. You should install it. How to install it now? In the next class, I will be explaining you. Don't worry. And who will make use of this JVM? JRE. Am I completely clear? Any confusions up to this stage? Now, whatever the diagram is there, just copy it as it is. I will give the points. Just pause and copy. Pay attention. Now, whatever I have told you in the form of diagram, you will be writing a very important diagram. So, this is your Java development kit software. So, if you ask me inside this JDK, what will be there, sir? Inside this JDK, you will be having one fellow called as JRE plus some more fellows called as developer tools. Oh. So when you install JDK, so you will be having JRE also and also what? Developer tools. What are the developer tools, sir? Developer tools like Java C, Java Doc, and Java. You know, why JDK is used? It is used to develop the software. Then don't you think so? In order to develop that software, you need some more people. That some more people are only called as developer tools. In the developer tool, we have one person called as Java C, which is nothing but Java compiler. And all the documentation of Java is available in Java Doc, and one more person Java. What is all these things? You will get to know, don't worry. So in order to develop this particular Java programs, JDK gives us one set of people called as developer tools. Not only that, in order to execute, I want one more person called as what? JRE, that is nothing but Java runtime environment. environment. In simple words, if you tell me what is JDK, it is nothing but the combination of JRE plus what? Developer tools. That is only called as JDK. And if you ask me, sir, inside JRE what will be there? Inside JRE, I will be having one fellow called as JVM plus some more person called as library classes. Oh. Sir, JVM we understood because you already explained. What is that library classes, sir? Whenever I think some students, when you written the Java program, you used to use this like this. Import java.lang. Import java.util. Import java.awt. Oh, what does it mean? Whenever you wanted to write the C programming language, what is the first two lines that you used to write? Hash include stdio.h, hash include conio.h. Why we used to use that hash include stdio and hash include conio.h? So whenever you want to print anything in the C language, which is the function that we use? Printf. Tell me, did you write the code for printf? No. Already some developers have written the code for printf, and whenever you call that printf code should be executed, and the developer has kept the code of printf function in one header file. That header file is only called as stdio.h. Similarly, in order to perform some activities in Java, already inbuilt classes or inbuilt support your Java developers have already made it. You will use that people and you will develop the Java applications. And if you ask me where the people are present, it is present inside this library classes. So some of the examples are java.lang, java.util. Like how you use hash include stdio, hash include conio. In Java we can import java.lang, import java.util like that. Anyway, those users and all, as we proceed, you will understand. And what is JVM, you already know. So, in simple words, if I ask what is JRE, it is the combination of JVM and library classes. Again I repeat, in detail we are going to speak about this library classes at all, don't worry. When I start the installation class, then you will understand what is Java, C, Java and all those things. Am I completely clear? Any confusions with this diagram? No confusions? One more important point that I want to tell you is, in the first day of the definition, I told Java is a programming language. Like how you have C and C++, .NET, like the Java is one programming language. Not only that, Java is environment or platform. What does it mean, sir? Environment or platform, what does it mean, sir? Think and answer correctly. If you want to develop Java programs, then which is the software that you use? With the existing operating system, can I develop Java programs? No. Along with it, you should install one more software. Which is that software? JDK. You should use that software called as JDK. Not only that, in order to type the Java programs, we will use something called as IDE. In order to type the Java programs, we will use IDE. Which are the IDEs that we use here? Eclipse. That is the IDE or Notepad++ or Edit+. These are all called as IDE. IDE means Integrated Development Environment. In that we type our Java programs. In the further classes, we will start with Edit+, then we will go for Eclipse. What is all that? Again I will explain, don't worry. So this is the environment that I want to set up in order to develop the Java applications. So without the JDK, I can't develop the Java applications. If I want to give one simple example, tell me, assume you fell in love with one girl. Just an example I am telling. You fell in love with one girl. On the road will you marry? Or in the bus stop will you marry? No. If you want to marry, you should create one environment. What is the environment that you should create? One big function hall or one temple you should book. Then all the relatives should be there. Then some music should be there. Not only that, very important, if it is a Hindu tradition, then Mangala Sutra should be there. This is the environment that you should create. With that environment only you can marry. Assume, if you want to cook any dish, you want to have an environment. What is that environment, sir? You should have the gas stove, vessels and the ingredients, all those things. Without that ingredients, without the gas stove, without the vessels, can you cook? No. Similarly, if you want to write any Java programs or if you want to develop any Java softwares, then you should create one environment. What is the environment? You should have JDK, and Java software only environment. Java people only gave that environment that, okay, fellow, if you want to write the Java programs or if you want to develop the Java programs, then you use this JDK. In order to type, we make use of IDE. Am I completely clear? So in other words, Java is not only a programming language, it is also environment or what? Platform. Now, everyone go to the first page notes that I have given in the first day class. There I have told, when written in the notes I have told you, Java is a programming language and I told you to leave one space, right? There you fill Java is a programming language and platform. Platform means what? Environment. It helps you to create the applications, softwares by installing what? JDK. Am I completely clear? So change there as Java is a programming language and platform like that you add it. After adding, come back. Again copy this diagram. Be quick. Pause and copy. Yeah. Now take down the points. Take down the points. Java software is divided into two parts. 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 First one, JDK. First one, JDK. Second one, JRE. First one, JDK, and second one, JRE. Second one is JRE. JDK is Java Development Kit. JDK is Java Development Kit. Java Development Kit used by Java developers. Used by Java developers. Used by Java developers to develop and execute Java applications. 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 Full stop in the next line. JDK consists of JDK consists of JDK consists of JDK consists of JRE and developer tools. JRE and developer tools. JRE and developer tools. JRE and developer tools. Next one, JRE. JRE. JRE is Java runtime environment. Is Java runtime environment. Is Java runtime environment which consists of JVM and library classes. 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 Full stop. JRE is used for execution of Java softwares. JRE is used for execution of Java softwares. Java softwares. Java softwares. Full stop in the next line. JVM is Java virtual machine. Java virtual machine. Java virtual machine. Java virtual machine that provides an environment. That provides an environment. That provides an environment. That provides provides an environment to execute Java programs. To execute Java programs. To execute Java programs. To execute Java programs by converting bytecode into native code in bracket machine level code full stop. JVM is a part of JRE. Now pause the video for about couple of minutes. Then slowly look at the diagrams that I have given on JDK, JRE and JVM. Read the points that I have given so that easily you can correlate and understand. Pause and see the points that I have given. Be quick. Now take the next topic, overview of Java architecture. A very important concept. Again, new things you'll be learning in this concept. Pay attention. Now, assume I will install JDK in my computer. Now I will start writing the Java program. Pay attention. Now this is the Java program that you have written. One Java program I have written. Now you know the Java program that you have written will be in the high level language, but in order to execute it should convert into the native code or machine level code. Now what I will do is I will give this Java program, whatever is there, to one fellow called as Java compiler. Now what Java compiler will do is it will generate one more file, and that file we call it as class file, and in that class file what code we have? Bytecode. So bytecode are such codes which is not high level code also, which is not machine level code also. Such code is only called as a bytecode and is obtained by compiling a Java program. This story you already know. Now this is your RAM. From now onwards, very important, pay attention. Now this is your RAM. Now in this RAM, you know JVM will be present. This is the RAM. So inside this RAM actually a small portion of memory is allocated. That small portion of memory only called as JRE. Inside the JRE, JVM will be there because you know JVM is nothing but a part of JRE. Now assume inside this RAM I have this fellow called as JVM. So JVM is present. If you ask me where JVM is present, it is present inside JRE. Where JRE is present, it is present inside the RAM only. So I will tell JVM is present inside the RAM. Now JVM will call one person by name called as class loader. So he will call one person by name called as class loader. Oh, okay sir, what this person will do? Name only telling class loader. What class loader will do is this class loader will help you to load the class file onto the RAM. Now JVM will tell class loader, I want to execute this class file. Please load it onto the RAM, because for any execution should come and sit on what? RAM. Immediately your class loader will pick this class file and it will put it on the RAM like this. So now your class file will be available here. Inside this what you have is the bytecodes. So you will be having the bytecode. So what is a class loader? It helps to load the class file into the RAM. Who will instruct that? JVM will instruct. Not only that, your JVM will make use of one more person called as bytecode verifier. He is one more important person. Okay sir, what this bytecode verifier will do? Bytecode verifier is like a policeman. He will check whatever the bytecode present in the class file is correct. Whether this bytecode is generated by Java compiler. kind of virus, like that it will cross check. I repeat, this bytecode verifier will check whether whatever the bytecode present in this class file, is it originally given by the compiler or not, or is it some kind of virus or not. So that part it will be checked by one person called as what? Bytecode verifier. So after these two, there will be one more person in your JVM. That fellow only, we call it as execution engine. Very, very important. Execution engine. In this execution engine, you will be having one fellow called as interpreter. Oh, you will be having one person called as interpreter. Okay, sir, what that interpreter will do? Once the class is loaded, once the bytecode verifier checks, yes, if everything is okay, whatever bytecode present in this class file is completely fine. Next, your JVM will make use of interpreter. What interpreter will do is, it will read the first line. So, it will read the first line, it will interpret, interpret is nothing but conversion of bytecode to what? The machine level language code. After that, it will execute. Again, it will read the second line, interpret, execute. Third line, read and execute. Again, read, interpret, execute. Read, interpret, execute. Read, interpret and execute. And you will get the output. So, this is what the story that is happening in your Java. But along with this interpreter, in your execution engine, there will be one more person called as JIT. Oh, who is the JIT, sir? JIT stands for just in time. Just in time compiler. What is that, sir? Just in time compiler. Already here one compiler is there. He is Java compiler, which converts high-level language code into what? Bytecode. Okay, sir, but here we have interpreter. Interpreter is the one who converts this bytecode into what? Machine-level language code. Bytecode to machine-level language code. Okay, sir. Then who is this JIT? When will you use this just-in-time compiler, sir? Listen carefully. Now, very, very important concept, something very new to you people. Assume I have one method called as fun1. One method is there. This is the code present in fun1. Now, after this, again I have some more lines, and again I will call one method called as fun1. Again I will call this method. Again some more lines are there. Again after some time I will call the fun1 method. Again some lines of code is there. Again I will call this fun1 method. Again after some lines code is there. After that again I am calling fun1 method. Again I am calling fun1 method. Assume this is the Java code. And this is your class file. Class file contains bytecode. Actually, if I write a bytecode, you will not understand. For your explanation purpose, I am writing like this and assume this is the code present in the class file. This is the bytecode present in the class file. For your understanding, I have written this in English. Actually, the code will not be like this inside the class file. For you people to understand, I am writing like this. Now, assume this is the code that is present in the class file. Now, class loader will load this particular class file into the RAM. Now, what the interpreter will do, before the bytecode verifier will check this code, everything is fine. He will tell, okay, no problem. Policeman green signal also. Now, the interpreter will start to execute the code. How he will execute the code? Line by line. Now, from the first line he will execute. So, in the fun1 method, he will read, interpret, and execute the first line. Similarly, second line, read, interpret, again execute, again third line, fourth line, fifth line, sixth line, seventh line, like that. Again, after this, he will read, interpret, execute, read, interpret, execute, read, interpret, execute, read, interpret, execute, read, interpret, execute. Again, after this, I am calling one method called as what? Fun1. Again, the control will go here. Again, this line, read, interpret, execute, read, interpret, execute, read, interpret, execute, completely. Again, I will execute this. Again, I am calling fun1 method. Again, I will execute all this line. Again, I will call fun1 method. Again, I will execute all this line. Again, execute this. Again, I am calling fun1. Again, all the lines present in the code of fun1 method execute. Don't you think so? That every time when I call fun1 method, I am going, reading the line, interpret, execute. Going, reading the line, interpret, and execute. Don't you think so? It is a tedious job. Don't you think so? It affects the performance of the execution it will make use of one variable called as count. And it will check how many times that method is getting called like that. Always the initial value of the count will be 0. Now, first time I am executing the fun1 method. How it will execute? Like this only. Read the first time, interpret, execute. Read the first time, execute. Read the next line, execute. After that, some more lines are there, it will execute. Now I am calling the fun1 method. So for the first time I am calling the fun1 method, hence your JDK will increment the value from 0 to what? 1. Again, now also what it will do? Again it will read the first line, interpret, execute. Read the second line, interpret, execute. Read the next line, interpret and execute. After that, from here the control gets here. So now again this line gets executed. Again I am calling fun1 method from here. Again, read, execute. Now this time at what time I am calling? Second time I am calling, hence it will become 2. Next, again I will execute. Now again I am calling fun1 method. Now I am calling this fun1 method for how many times? Third time. Always remember there is a limit for JIT. Whenever it crosses more than 2 times, your JIT will get to know, oh, fun1 method is such method that this person is getting called multiple times. Then what JIT will do is, JIT immediately converts this method, which is in the form of bytecode, into machine level code. It will convert. Immediately it will convert. Now, when I am calling for the second time, for the third time, see here, this time line by line executed. This time line by line executed. Now, when you call this time, that is for the third time, immediately your just-in-time compiler will be activated and he will convert that entire code into what? Machine level code at once. Now for the third time when I am calling, I will not read line by line, rather I will directly execute this machine code. Next again after that I will execute. Now again I am calling fun1. We will not go and read line by line, rather already this method, machine level code is present, that code gets executed. So that is the duty of just-in-time compiler. If you ask me, when will we use just-in-time compiler? Whenever a method or a function is called multiple times. How many times? Maybe more than 2 times. Then the just-in-time compiler will get activated. It will convert the bytecode of that method to what? Machine level code. And in future, if you call that method, rather executing the bytecode, it will execute what? Machine level code. Am I completely clear? Did everyone get to know when interpreter will be used, when just-in-time compiler will be used? For the first time when you call, interpreter only will be used. Second time when you call, interpreter only will be used. When you call for the third time, just-in-time compiler gets activated, convert the entire bytecode to machine level code. From now onwards, this code only get executed. Am I completely clear? Any confusions? Now, okay sir, in my program, who will tell me that this program is executed for 2 times, 3 times, 4 times, 5 times and all? For that, Java makes use of one fellow called as profiler. Oh, what does profiler will do, sir? Profiler will check in your Java program which method is called more than 2 times, more than 3 times. If you are calling the method for more than 2 times, then immediately profiler will tell to JDK, this method is getting called more than 2 times. So be careful. So you should be activated and you should be helping to convert this code into what? Machine level code. So profiler helps us to identify which method is getting called multiple times. And whenever you try to call more than 2 times, then at that time JDK will get activated, convert the bytecode into what? Machine level language code. So till that time, who will convert that bytecode to machine level code? It is interpreter. Am I completely clear? So these peoples are present inside the execution engine. Apart from this, there are some other people also that I will explain when time comes. That's why if you read the heading I have given, just overview I have given. Not deep architecture I have given. Deep architecture, after learning the concepts, I will come back and I will tell you. So inside JVM, all these people will be present. So who are they? Class loader. Helps to load the class onto the bytecode verifier. Check whether your class file is generated by the compiler or it is some kind of virus or not. Interpreter helps to convert the bytecode to machine level code line by line. Whenever your method is called for multiple times, then just-in-time compiler will be activated, convert the bytecode into what? Machine level code. And who will help to do that? Profiler will which method is called multiple times. I hope no more confusions. Whatever the diagram that I have given, copy it as it is. I will give the points. Be quick, just pause and copy it. Now take the points. Take the points. Under that, JVM consists of first point, class loader, hyphen, which helps to load the class file onto the RAM. Which helps to load the class file onto the RAM. Which helps to load the class file onto the RAM. Which helps to load the class file onto the RAM. Next point, bytecode verifier. Next point, bytecode verifier. Next point, bytecode verifier. Bytecode verifier helps. Bytecode verifier helps. Bytecode verifier helps to check whether the bytecode. To check whether the bytecode. To check whether the bytecode. To check whether the bytecode present in the class file. Present in the class file is generated by the valid compiler or not. 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 Next one, interpreter, or you take out execution engine. Next point, execution engine. Execution engine. Under that subpoint, interpreter. 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 This helps to convert. This helps to convert. This helps to convert bytecode to native code. To native code. To native code. Line by line. Line by line. Line by line. Full stop. Next subpoint, JIT. Under that, JIT stands for just in time compiler. JIT stands for just in time compiler. Just in time compiler. Whenever repeated method calls occur. 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 See here. Whenever repeated method call. Here also I am calling, here also I am calling, here also repeatedly I am calling. So whenever repeated method call occurs, then JIT gets activated. Then JIT gets activated. Then JIT gets activated. JIT gets activated and helps to convert and helps to convert bytecode to native code. Bytecode to native code. Bytecode to native code. Full stop. This native code will be used directly. This native code will be used directly. For the repeated method calls. For the repeated method calls. Full stop. In the next line. The problem with the interpreter is whenever a method is called multiple times, whenever a method is called multiple times, then it will execute. Then it will read line by line. And convert bytecode to native code. Again and again. This problem can be overcome using JIT. This problem can be overcome using JIT compiler. See here, pay attention everyone, what they are telling. So whenever, assume this JIT is not there means, so whenever you call this method multiple times, then your interpreter will read line by line, convert bytecode to native code again and again. First time when you call, it will convert. Second time when you call, again read, convert from bytecode to native code. Again read, convert. Again read, convert. Again and again it will be converting. So how to overcome this problem? Call JIT. JIT will convert all this bytecode into machine code at once. Why? Because it is a compiler. Once it will convert. So that is what the point that I have given. Full stop. In the next line. The method which gets called multiple times. 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 The method which gets called multiple times is only called as hotspot. Is only called as hotspot. HOTSPOT. Is only called as hotspot. Pay attention. Notice here. Now tell me in this program, which is the method which is calling multiple times. Fun1. So this method is getting called multiple times. Whichever the method that is getting executed multiple times, that method only we call it as what? Hotspot. So in the interview, they ask what is hotspot. So in a program, if a method is called multiple times, repeatedly when you call this function many times, then that method only we call it as what? Hotspot. So in the diagram, just point the arrow and make it The next subpoint, profiler. 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 It is responsible to identify the hotspots. 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 I hope you understood all the concepts that I have put inside the JVM. But this is not the detailed architecture of JVM. Inside this JVM, there are other peoples also. When I tell class product, there are so many things I want to explain in detail. At this point of time, if I explain, you will not understand. So once the concepts get completed, I will come back and I will give this architecture once again. Now in the next page, you take this heading in a completely new page. In a complete new page, take the heading as JVM Deep Architecture. JVM Deep Architecture. JVM Deep, D-E-E-P. JVM Deep Architecture, leave that page blank. One complete page you leave the blank. Because once after completion of certain concepts, I will come back and again I will explain what are other people present inside this JVM and all. So am I completely clear? Any confusions? So whatever the points that I have written, read once completely. Take the next question. Again this question they have asked in interviews many times. Why Java is both? Why Java is both? Why Java is both compiled and interpreted language? Why Java is both? Why Java is both compiled and interpreted language? Why Java is both compiled and interpreted language? Why Java is both compiled and interpreted language? Yeah, pay attention. Now you know this concept already many times I have explained. So the Java program that you write, it will be in the high level language. But for the machine, it will understand only the machine code or the native code or the binary code. All of them are same. Now it is your duty to convert from the high level language to the machine level language code. So for that, what Java will do is, Java will make use of one compiler called as a Java compiler. What Java compiler will do, Java compiler will convert your high level language and Java program code into what? Bytecode. It will not convert into executable code or native code or machine code. It will convert into what? Bytecode. Now that bytecode will be taken by one person called as JVM with the help of interpreter. It will convert bytecode line by line to what? Machine code. And not only that, whenever the method is called multiple times, then that particular method will get executed by one fellow called as what? JDK. So hence, in execution of Java program, I am using compiler to convert high level code into bytecode, and I am using interpreter to convert bytecode into what? Machine code. Hence, Java is both compiled and interpreted programming language. So this you should explain when they ask this question. Am I completely clear? Copy this diagram. Pause and copy. I'll give the points. Just copy it. Yeah, take the points. Java is both compiled and interpreted programming language. Compiled and interpreted programming language. Interpreted programming language. Full stop. In Java, after compilation, the code will not get converted into executable code or machine code. Executable code or machine code. Executable code or machine code. rather, 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 it gets converted into bytecode. 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 Full stop. This bytecode will be given to the JVM. 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 And with the help of interpreter, with the help of interpreter, the bytecode is converted into executable code. 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 Okay. So hope you got to know that if someone asks what is Java, is it compiled language or interpreted language, your answer should be it is both. So today I will end this session at this point. Tomorrow we will see some more important topics, that what are the features that made Java one of the popular language even after 20 years. So Java invented in 1990s. Even after 20 years, this is one of the widely used programming language. If you ask me why, then wait for my next video. Thank you.